Alaikum everyone, and today we're going to learn basic trigonometric identities. So now that we know all the 6 trigonometric functions, we want to learn some identities of trigonometry. So at first we're going to list all the trigonometric functions and the reciprocals, obviously. And now we have to understand one thing. If these are going to be the reciprocals of each other, it'll be something like this. 1 over sine theta, 1 over cosine theta will be the secant, and 1 over tangent theta would be the cotangent. Now, we have to understand another thing, is that tangent of theta equals to sine of theta over cosine of theta. Don't worry, this is all related. Don't worry. We are still going to learn these. At first, this makes sense, because if you think about it, it's going to be opposite over hypotenuse over adjacent over hypotenuse. The hypotenuses cancel, leaving opposite over adjacent, which is going to be tangent. So that also means that cotangent could be described as cosine of theta over sine of theta. Now that we have covered all these, let's learn some trigonometric identities. So the first identity groups we're going to learn is the Pythagorean identity. For that, we have to bring back the Pythagorean Theorem. And if you don't know what the Pythagorean Theorem is or how it works, there is link in the description and watch it right now. Otherwise, this video would make no sense. At least of this. At least. Key. Pause the again.
Continue.
So, as we can see from our Pythagorean Theorem video, a squared plus b squared equals to c squared. Now, let's divide all of the sides by c squared. So, it would be a over c whole square plus b over c whole square equals to 1. And since this is going to be the opposite and this is the hypotenuse, we can use this as sine of theta squared. Although in trigonometry, in these functions, the exponent would be here, which we will tell as sine squared theta. So, this plus, now this is the adjacent, and this is the hypotenuse. Adjacent over hypotenuse. Cosine squared theta, which will be equal to 1, since hypotenuse over hypotenuse would be 1. So this is our first Pythagorean identity. grating sound আসবে। So now we've got this identity covered. We have some other Pythagorean identities to understand, because surely this is not the only identity. So let's do one thing and divide all of the sides by cosine of theta. Yes, I really said that. Divide everything by cosine of theta. Cosine squared theta. Actually, my bad. And if you saw the beginning of the video, you would understand 1 over cosine squared theta would be secant squared theta. And if you know anything about fractions, you know these cancel out, leaving 1. And if you again saw the beginning of this video, you would understand that sine over cosine is tangent. So this will be tangent squared theta. Now there are 2 identities covered. Let's find the third identity, because there is a third one possible. You see, these are Pythagorean Theorem, Pythagorean identities, because these kind of match with the Pythagorean Theorem. So, sine squared theta plus cosine squared theta. This identity would be used a lot in trigonometry, so you better memorize it. Let's go the other way and divide everything by sine squared theta. And everything. Now, these cancel out to be 1, plus these would be cotangent squared theta reciprocals. And this, since the reciprocal of sine is cosecant, this will be cosecant squared theta. So here is the third Pythagorean identity down. So these are the Pythagorean identities. See you next time. Wait, just kidding. We have more identities. You thought these were gonna be the only identities? Nope. So let's check out the other identities. So now we will learn the confunction trigonometric identities. Yup, there are more. And this time we have to go back to the unit circle. Again, link in the description. Watch it, otherwise this video would make no sense. Or this part of the video, obviously, because you didn't need to know the unit circle at the first part. Anyways, all side notes aside, let's understand some things first. So in the unit circle, we would understand that the sine of 0 degrees equals to 0, and the cosine of 90 degrees equals to 0. Now if the sine of 30 degrees is 1/2, and the cosine of 60 degrees equals to 1/2. I know this is starting to feel boring, but trust me, by all these, we can find out a an equation that is sine of theta equals to cosine of 90 degrees minus theta. So when this was gonna be 90 degrees, stuff. So if this was going to be 90 degrees, the sine of 90 degrees would be 1, because 90 degrees minus 90 degrees, the cosine of 0, and the cosine of 0 is 1. Again, link in the description on the unit circle. I know this is confusing otherwise. By doing a little bit of algebra, we can find out the cosine of theta equals to sine of theta, sine of 90 degrees minus theta. And we can replace these functions like tangent of theta would be cotangent of 90 degrees minus theta, and the cotangent of theta equals to the tangent of 90 degrees minus theta, or we can do this to the secant. That's what I call it. Secant of theta equals to the cosecant of 90 degrees, blah, 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 blah. Yeah. So by all that, after all that exhaustion and dizziness, we finally have done it. All of the trigonometric identities. So that's all there is to it. You can subscribe to my channel for more videos. You can subscribe to my second channel, Uziman Codes, where I do some coding, HTML coding stuff. You can watch that. And as always, thank you for watching, and I will see you next time. Bye.